How are you, my dear children? Hope you all are safe and fine. Today we are going to discuss about multiplication of vectors. Okay, we have already discussed addition, subtraction, everything. Now today we are going to discuss how you will do the multiplication of vectors. Okay, so first is when you multiply a scalar with a vector, then what will happen? What result you are going to get? Or let us see. When you multiply a scalar with a vector, you are going to get vector. Always you will get a vector. Okay, let us realize. Take an example. Suppose let us take a vector A is equal to 3i cap minus 4j cap plus 2k cap. Let me multiply a scalar. Let me multiply 2 with vector A. Then what I am going to get? Simply just multiply 2 with vector A. That means you will get 6i cap minus 8j cap plus 4k cap. Okay. Now you can see here we have multiplied a scalar with a vector. See the result now. It is again a vector. Clear, children? How we are getting a vector when you multiply a scalar with a vector. Let us see it with the day-to-day example how we are going to get a vector when you multiply scalar with a vector. Let us take a object, okay, having mass m. Now you are moving the object with acceleration a, and you know acceleration is a vector quantity. Okay, acceleration is a vector quantity. Now when you multiply this mass with acceleration, what we are getting? We are getting force. This thing you know, force, and you know force is also a vector quantity. Can you feel it right now? This is your scalar. Number simply a value. Scalar means it has not no magnitude, no direction. Sorry, it has got magnitude only. That means value only, number. And acceleration is a vector quantity. So now your force is a vector. Clear? Now we'll move to the second type of multiplication of vectors. Okay. What is the second type? When you multiply a vector, with a vector, then what is the result? Immediately we will tell, no, we are going to get vector. No. We can get a scalar also. Result can be a scalar. Okay. And result can be a vector. Okay. When we are getting scalar means this product, we'll call it as scalar product, or you can say dot product. Okay. This is not normal multiplication, children, how you are multiplying. This is a operator. Okay. And vector means we'll name it as vector product or cross product. We'll see one by one. Today only we are going to discuss about all the dot product. How you write? Suppose there are two vectors A and vector B. As the name is suggesting, we'll put a dot over here, A dot B. So we'll get the result C. Now this is what we are getting when we multiply a vector with another vector, but that is dot product. Then our result is scalar. That means only the value. So this is a scalar quantity. Only it has got magnitude, no vector, no direction. That means. Okay. day-to-day example. What is the example? Work done. You know, work done is equal to force into displacement. Force into displacement, you know. This thing you have studied in class 9. Now, how you write? We'll write over here, work done is equal to force is F. Okay. You know force is a vector dot S or D, whatever you are denoting your displacement. So now as you can see, this is your vector. This is also vector, but work done is your scalar quantity. Clear, children? This example. Now in case of this vector product, how will you write? Again we are taking two vectors, A, then cross. Don't say it is multiply, it is cross. Okay. B, we are getting the result C, but it is a vector quantity. Okay. Again, you have not studied, but we will study later, that is torque. Torque is, formula is displacement. In rotational motion, we will study this. Displacement with force. That means, notation is tau. It is a vector quantity. Again, the position vector, that is your displacement, you will study later this thing, are again a vector, cross force, you know a vector. Okay. So this is the example of vector product or cross product. Is it clear, children? Now we'll see the dot product of two vectors. What is the dot product of two vectors? Dot product of two vectors. How to do? See two vectors. First vector is, the first vector is vector A. Then another vector is vector B with a angle theta. Both the vectors are having angle theta. Now, what is the formula? A dot B, that is the dot product of two vectors. Formula will be magnitude of vector A, magnitude of vector B, and cosine of the angle, cos theta. This is the formula. Or simply you can write AB cos theta. This is simply magnitude, means we are talking about only the value, the number. Okay. Now we'll discuss some of the special cases. We'll discuss some special cases. First one. When both the vectors are in same direction. What does it mean? That means when two vectors are parallel, or you can say, or when two vectors are parallel. Then what is the angle between those two vectors? Theta will be 0 degree, you know, in this case. Okay. So, what is A dot B now? A dot B will be simply magnitude of A. We will write it as A, that is only number. Then B, the value. I am talking about the value of the vector A. Magnitude, not the direction. So, A, B, then cos theta. What is theta now? Cos 0 degree. What is cos 0, children? Value is 1. That means we are getting AB. Okay. This is your maximum value. Maximum value. When you take dot product of two vectors, when theta is equal to 0, we will get AB. A dot B is equal to AB. Now, have you noted it down? We will now discuss the second case. Let me clear the board. We are discussing dot product of two vectors. Okay. Now what is the second special case? We are discussing special case only. Let me write over here again. Special cases. Now the second case. So second case is when theta is equal to 180. What does it mean? Theta is equal to 180 means both vectors are in opposite direction, or you can say when two vectors are anti-parallel. Then what will happen? So what will write? A dot B, what is the formula? A, B, then cos 180. What is the value of 180, children? Cos 180. Cos 180 means minus 1. That means we will write A, B to minus 1. Okay. So A dot B will be now minus AB. Clear, children? Easy. Now we will discuss the next case. What is the next case? Next case will be the third one. When both the vectors are perpendicular to each other. When both vectors are perpendicular to each other. Then what will happen? What is the angle between them then? Then theta will be 90. So in this case, your A dot B will be how much? A, B, cos 90 will write. What is cos 90? We know cos 90 is 0. So that means it will be 0. Clear, children? That means it is very, very important. Very important point. Okay. So if A is perpendicular to B, that means the dot product of both the vectors you will get 0. Clear, children? Now fourth case. When theta is acute. Acute means what is the angle? What is the criteria? That means theta is less than 90. So less than 90. So what is cos? Cos value? Cos 90 na? Less than 90. So it will be positive. That means your dot product will be A dot B. If you are talking about two vectors A and B, so their dot product will be positive. So you will get dot product. Result will be positive. Dot product will be positive. If theta is obtuse, that means theta is greater than 90. Okay. So your dot product will be, dot product will be what? What result you will get? Dot product is negative. Clear, children? These are the special cases of the dot product when we are taking the dot product of two vectors. Clear? Now let us see what is the physical or you can say geometrical representation of this product. Okay? Physical or you can say geometrical interpretation of dot product. See, this is your vector, first vector. Okay. Now this is your second vector. Let us be. This is your V vector and the angle between the vectors is theta. Now we know A dot B. How we are writing? This is simply A, B, that is magnitude of A, magnitude of B, then cos theta. can we write as simply A B cos theta? We can write like that. Okay, because these are value only. These are simply value. What I am going to do now, we'll draw a perpendicular like this over here. Now tell me, what is the value of this? You know this is B cos theta? Yes or no? This is the, what is this? This is known as the shadow of vector B on A, or you know, this is called the projection of vector B on A. Clear? That means dot product of two vectors means this is simply A. What is B cos theta? B cos theta is the, you can say, component of vector B. You know how to find out the component. We have already discussed in our previous lectures. So component of vector B along A, along vector A, along vector A. Is it clear, children? This is the physical or geometrical interpretation of your dot product. Clear? Or otherwise, suppose this is your vector A and this is your vector B. Now I'll write AB dot product of A dot B. I can write like this also because this is scalar, so I can exchange this. Okay, I can write like this also, no harm. So what I'll do now? Now this is your theta. I'll draw the perpendicular over here. Okay, I'll draw the perpendicular from here to on B. So what is this value now? Tell me the value. This will simply A cos theta. Okay, that means this is the projection of vector A on B, or you can say this is the shadow of vector A on B, or you can say it is the component of vector A on B, or you can say component of vector A along B. Okay, so we can write like this. So A dot B, we can write like this. A dot B is the product of, you can say like that, product of magnitude of B. This is magnitude only, okay? Magnitude of B with what? With what? Tell me. Component. I can write like this over here. Component of vector A along vector B. Is it clear, children? So this is the product A dot B, means we can write the B, that means the magnitude of vector B, and will take the product of magnitude of vector B with the component of vector A along the vector B. Is it clear, children? Physical interpretation. Now we'll move to the properties. What is properties? We'll discuss one by one. Properties of dot product. What are the properties? Easy one, just very simple one. Maybe cross product you will find little bit of tricky, but dot product is very easy, but very important. Okay. First, dot product is commutative in nature. You know from mathematics what is commutative law. That means A dot B we can write as simply B dot A. Okay, that means A dot B means, what is AB? We know it is AB cos theta. What is B dot A? BA cos theta. So is it commutative, na? These are only values. This is scalar quantity. So we can exchange the position. Okay. Now second one. Dot product is distributive in nature. distributive in nature. That means A dot B plus C. How will you write? We'll take out the brackets. Okay. We can simply write A dot B dot product of these two vectors plus dot product of A dot C. This also you can do like this. Okay. So this is the second property of the dot product. Now the last one, again the important one. Let me clear the board. Dot product third properties. Okay. Third one. Dot product of a vector with itself gives square of its magnitude. Gives square of its magnitude. What does it mean? Magnitude means only value you know. So dot product of a vector with itself, that means A dot with itself, A dot A. So what is the angle? If it is A with itself, A, so angle will be how much? With itself. Then angle will be how much? A cos 0 degree. Okay, you know two vectors A, B cos theta. So here two vectors means A, then 0 degree. And you know cos 0 is equal to 1. So that means A square. Very, very important result, children. Remember this one. It will help you in numericals. Okay. This is a very important result. Dot product of a vector with itself gives you the square of that vector. Okay. Now we'll see what is the dot product formula for orthogonal unit vectors. Okay. We'll move to next part, that is dot product of orthogonal unit vectors. Orthogonal unit vectors, you know, we have already discussed. So we'll take three vectors, x, y and this is your z. Okay. Now what is the unit vector in x direction? You know unit vector in x direction will be, let me write with this, I cap, and unit vector in this is j cap, and here it is k cap along the z direction. This thing we have also discussed. Orthogonal means all are perpendicular to each other, all the vectors. Okay. Now we'll write I cap dot I cap, or you can write j cap dot j cap, k cap with itself. Okay, just now we have seen a square I square. We can write, but here we'll see what is the formula. Formula will be I cap, then again I cap. You can say cos 0 degree for I cap and I cap. So this is magnitude is 1, this is 1, and cos 0 also 1. So that means 1. Similarly for j and k, so it will be 1 only. Is it clear? That means if you take the dot product, unit dot product with the itself, the value will be 1. Okay. Now what is the dot product with other unit vectors like I dot j, or you can say j dot I? What is the value? We'll write I cap, then j cap, then cos. What is the angle between I and j? You know it is 90 degree to each other, orthogonal. So 90 degree. And these are unit vectors. So 1, 1 and cos 90 is 0. That means 0. Is it clear, children? That means what we are getting? I dot j, j dot I is 0. Or you can say j dot k, k dot j is also 0. Or you can say I dot k, k dot I is also 0. Okay, we'll summarize this thing what we have studied just now. Let me clear it. So we'll summarize now. I dot I cap with itself, j dot j cap, k dot k cap is equal to 1 with dot product with the other one, not with itself, or you can say j dot k, k dot I. Okay, this is 0. Remember this. Is it clear, children? So this is the formula, or this is the criteria, or this is the result, this is the value of dot product of orthogonal unit vectors. Now we'll see how to do the dot product in Cartesian coordinates. Let me clear it out. So easy, but you have to keep patience. Dot product in Cartesian coordinate. In Cartesian coordinate. How to represent? Have you remember, children, how to represent vectors in Cartesian coordinates? This thing also we have discussed. So A is given by AX I cap, AY j cap, then AZ k cap. Then what is B vector? B vector is BX I cap plus BY j cap plus BZ k cap. This thing you know. Now we want to find out A dot B. That means what we will write? AX I cap plus AY j cap plus AZ k cap. Okay, dot BX I cap plus BY j cap plus BZ k cap. Okay, now what we'll do? We'll take 1 with the entire vectors. Just open the bracket. How I'll do the multiplication? Na? So simply what we'll do? AX I cap with the entire second vector dot BX I cap plus BY j cap plus BZ k cap. Okay, plus AY j cap dot BX I cap plus BY j cap plus BZ k cap. Now the last one, this one, plus AZ k cap dot BX I cap plus BY j cap plus BZ k cap. Clear, children? Now what we'll get? Now see, AX I cap with BX I cap. So what we'll write? AX BX I dot I. Okay. Now AX I cap with BY j cap. So what we'll write? AX BY I dot j plus AX I cap with BZ k cap. So how will you write? We'll write AX BZ I cap plus I cap dot k cap. Okay. Similarly for this, in same fashion, we'll write AY BX. Do it on your own. J cap I cap plus AY BY j cap dot j cap plus AY BZ j cap dot k cap. Okay, plus, now for this, all you write, you will write AZ BX K cap dot I cap plus AZ BY K cap dot J cap plus AZ BZ, what will write, K and K cap dot K cap. Clear, children? Now as you can see here, see it is I cap dot I cap, that means 1. Just now we have seen I dot J cap, that means it is 0. I dot K cap, that means it is 0. So what we are going to get now? A dot B is equal to, this term remains because I dot I is 1. So we'll write AX BX plus, now see over here, AY BX, this is also 0, J dot I, but here J dot J is 1. That means second term will be AY BY. And again as you can see here J dot K is 0, so this term also becomes 0. Okay. Now here also come to this term, now K dot I 0, K dot J 0, but K dot K is 1. So our next term will be AZ BZ. Clear, children? So this is the dot product. Okay. I'll write the result again. Okay. Easy one. So your A dot B is equal to AX BX plus AY BY plus AZ BZ. This is the formula of this dot product of two vectors in Cartesian form. Okay. Now we'll see what is the application of this dot product. Why we are studying this? How we'll use this? Okay. So we'll now discuss the application of dot product. First one, very important one, to find the angle between two vectors. Okay, we can find out the angle between two vectors. We know A dot B is AB cos theta. This thing you know. Okay. So that means we can write cos theta is equal to A dot B by A dot this product of, this is the value. We can find out the angle. Okay. These are values only. You can see these are values. Okay. Or simply you can write theta is equal to cos inverse of A dot B divided by magnitude of vector A with magnitude of vector B. This thing also you can write. Clear, children? So this is the first application. Then second one. Let me clear it out. Second application of this dot product. To calculate the component of vector B along vector A. Or other way around also. You can calculate the component of vector A along the vector B also. So what is the component? You know this is your vector A and this is your vector B. And we have drawn the perpendicular and this is angle theta. So this is the component. B cos theta is the component of vector B along vector A. Then you know this component is equal to is B cos theta. So how to find out this B cos theta? A dot B is equal to A magnitude of A, magnitude of B, B cos theta. So from here you can write B cos theta is equal to A dot B divided by vector A. Sorry, magnitude of A. So this is the formula. See, this is the value of component of B. This is the component of B along vector A. So this is the formula A dot B. You take the dot product divided by the value of vector A. So this is the formula for finding out the component of B along vector A. Okay. Suppose in question there is no angle given, then how to find out? You can say other formula also. That means we can write, see, I can rearrange this formula, right? I can write like this. Same way, just I have changed the position. So what is this, children? This is nothing but unit vector, na? You know this. So we can write also component of vector B along A is equal to simply vector B dot A cap. Clear, children? This way also we can represent. Okay, this way also we can represent, or we can represent like this. Clear, children? Okay. Now last one. How to use this dot product? See, we can find out the condition for perpendicular vectors. That means to calculate the condition of perpendicular vectors. That means if in question is given, two vectors will be given and you have to find out whether these two vectors are perpendicular or not. Then what to do? We have to find out the dot product of these two vectors. If the dot product is 0, we have seen, then both the vectors are perpendicular. So if dot product of the vector is 0, then both the vectors are perpendicular to each other. Clear, children? Okay. We'll see all the numericals, but not in today's video. So A dot B is equal to 0. That means dot product of two vectors is 0 when both the vectors are perpendicular to each other. So that means in question is given vector A will be given, vector B will be given. You have to find out whether these two vectors are perpendicular or not. Simply take the dot product. If dot product is 0, that means both the vectors are perpendicular. If it is not 0, then both the vectors are not perpendicular. Easy, children? So this is all about the dot product in details. So video length will be really more. Now already 38 minutes is over. So we'll discuss numericals in my next video of this dot product, whatever theory we have studied today. So we'll take the examples, we'll discuss numericals, because numericals really huge of this dot product and cross product and very important for exams and NEET and your JEE mains. So in my next video lecture we are going to discuss about the numericals of the dot product. Hope this video lecture helps you in some way, or I am making it easier. I don't know, I am just trying my best. Okay. Thank you for watching, children. Take care. This is a tough time for each and everyone. So stay safe and take care and study well. Thank you.